All right, so we're going to do a really quick summary, and it's going to be quick, of exponents. It'll be real fast. Boom, boom, we'll be done. So we've used exponents pretty frequently. Probably you've used exponents at the last 4 years of math. They've been sprinkled throughout. This note sheet is identical to the note sheet that we did back in chapter 1. I had this identical same 6 properties last year in algebra 2, and you've probably seen the identical 6 properties back in algebra 1. So CADE, if you have a to the m, a to the n, what do you do with the exponents? How do you put them together? That'll be down here. There you go, you add them. Yeah. So when you're multiplying the bases, if the bases are the same, you add the exponents together. And then the exact opposite property, if you're dividing and the bases are the same, you subtract the exponents. So that's the way to combine them together. And when I would teach it, kind of as an intro, you can kind of expand the powers and see how things subtract, reduce, or combine together, depending if you're multiplying or dividing. But you could actually see a whole bunch of bases repeated and see how that works. Hopefully you were shown that years ago. So C is the one that you actually multiply. That's an exponent to an exponent. So power to a power, you multiply those together. Virginia, letter D, when you have 2 different bases with powers. Yeah. So that R kind of distributes to the exponents, and it goes with the M and the N. So the exponents don't have to be the same. The bases don't have to be the same. That little power on the outside just distributes through. And then the 2 negative exponent properties, Chelsea, a to the negative 1 is? 1 over a to the 1. So the exponent doesn't change the value, it's just moving down to make it a positive exponent. And then F, Chelsea, a over b to the negative 1 is the same as b over a. So when you have a fraction to the negative exponent, it's really just taking the reciprocal. So 6 problems at the bottom are pretty straightforward. The ones on the back just get slightly more interesting. But if you notice, we're doing rational exponents, which means they're fractions. So we're not looking at having a squared and a cubed and adding the exponents. Instead, we have a to the 1/2 and a to the negative 1/4. So how would you add those exponents together? Chelsea?
It would be 1/2 plus negative 1/4.
So the 1/2 really becomes 2 over 4, which is what Chelsea was kind of doing mentally there. And then that becomes just a 1/4. So getting a common denominator, 1/2 with a common denominator is really 2/4, plus a negative 1/4 makes a positive 1/4. So Eris, number 2, x to the negative 1/3 becomes?
1 over x to the 1/3.
Yeah, 1 over x to the 1/3. So the power isn't changing, it doesn't become a cube. Power is still the power. The negative part moves to the bottom to make it a positive exponent. You don't have to write these in radical form. We're just keeping them as rational exponents, so you don't need to worry about rewriting any of them. And then the third one, we have this power on the outside. So this kind of just goes through your properties a little bit here. So Michael, z to the negative 1/2 to the 4th is? Nice job, 1 over z squared. Pretty straightforward. So Brandon, the next one, we are dividing. What would these exponents become if we got to get a common denominator, Brandon?
It would be 4, 6 minus 3 6, which would be 6.
Right. So common denominator is a 6. 2/3 is 4/6. 1/2 is 3/6. And he subtracted them, and he said the common denominator would give us a 1/6. So get your common denominator, convert them, and then you're still subtracting. Number 5, we have 3 exponents. A negative 1/2 the middle x has a 1, and then the last x has a 2/5. What would the common denominator be with those three? Kate? 10, yeah. So Kate, -1/2 would really be negative 5/10. 1 would be 10/10. And then 2/5 would become 4/10. So when you combine all those together, Kate, you end up with?
9/10?
Yeah, 9/10. And then last one on this side, lots of b's up here. So getting a common denominator again with those b's in the top part of the fraction. So 3/2 and -2/3. Virginia, what would the common denominator be? 6. So 3/2 becomes 9, 6. -2/3 would be -4/6. And then Virginia, when you add the exponents in the numerator, 9/6 minus 4/6. Yeah, it would just be 1. So when you have the exact same base and exponent divided by the exact same base and exponent equals what? Not 0. That's just like 2 divided by 2, 15 divided by 15. The same thing divided by the same thing is 1. Questions? Alright, 3 more. I think number 7 is probably the most interesting one because it has a number in it. It's the only one with a number, like a whole base instead of a variable base. We just have a 9. When you distribute the exponent through, does it also go to the 9? Yes. So that 9 technically has an exponent of a 1. The 3/2 has to go to all of the exponents, even the number. So that would be 9 to the -3/2. Now the others, remember you're multiplying them. So you're multiplying those two fractions. So Brandon, we're taking -2/5 times -3/2.
Oh, 6
And 6/10 reduces to
3/5.
3/5. Good job. And then Brandon, K has 4/3 times -3/2.
-2.
And that's a -2. Nice. You need to kind of just take your time mentally, top, bottom, reduce. Alright, so the negative exponents move to the bottom. So 3/5 is the positive staying on the top. 9 to the 2/3, K squared, those move to the bottom. Now without your calculator, which I think most of you, I don't know, does anybody have a calculator for this? I think things like, okay, of course. So Cade, what do you do with 9 to the 3/2 without your calculator? Yeah, so you don't need that on your desk. So when you have an exponent and it's as a fraction, the denominator makes the root. So a square, a 2 on the bottom, is a square root. The numerator is the exponent. You can do either one. So you could take 9 cubed first, which might be pretty hard to do mentally. Or you could just do the square root of 9 and then cube it. So Cade, the square root of 9 becomes, and 3 cubed is 27. So sometimes it's easier to do the square root part, get a small number, and then apply the exponent outside. And then K squared H 3/5. Any questions on number 7? So I think that was probably the most interesting one, in my opinion, because it had the number in it. Alright, so looking at 8, Nick, how's your mental math today?
Not that good.
Not that good. I guess at least you're honest. All right, Nick, if we take -2/3 times -3/4. written up here for you.
Uh,
So negative 2 and negative 3 make,
uh, 6.
okay, and 3 times 4 is,
12.
so 6 divided by 12 is,
2. 6 divided by 12. Half.
there you go. Look at that, that wasn't too bad, right? Alright, one more time, Nick. Negative 4 times 3 over 4.
Uh, 12 divided by 4, so it's 3.
There you go. Hmm?
Yeah.
Positive? Oh, because that was a negative. Yep. My fault. Positive. Go with what Nick said. Alright. And then, Nick, the last thing you'd have to do with this one would be?
To the
What do you do with that x to the negative 3/4?
you move that down.
Yeah. So y over the 1/2, x to the 3/4 Questions? The last one has some c's and d's. So Virginia, c to the 5/2 times positive 2/3. That's 5/3. Positive. 2 positive powers. Alright, d negative 3 to the 2/3. Right, nice. And then on the bottom you have c to the negative 1/2 and then 2/3. Negative 1/3. So if we move this c to the negative 1/3 to the top, Chelsea, what happens with the c's? It's a 2. So the negative exponent moves to the top, and right there we have c to the 1/3, c to the 5/3. So that's just 2. That's 6/3 or 2. The d to the negative 2 has to move to the bottom and become d squared. Questions? No, because it's not equal to anything, so you're not solving. So I can't reduce it if I'm not solving for something else. Good question. Other questions? So the worksheet I have today is all exponents. It's a little small, but you have young eyes.
Wow, that's small.
So they get like left
I don't even know what number
I bet
five
your
is.
grandma has one of those like little magnifying glasses. You guys remember Mrs. Hirschman?
Yeah.
Shall she carried around that little magnifying glass with her when she read? Maybe you might need something like that.
I can see it fine.
Well, yeah, you can't, Brandy, because you write like so itty bitty. All right, so there's one thing that might be hard to read, even for Brandon. If you look at number 30, that's a negative 2/3 on the outside.
I can't see it.
The S has the negative 5/2. I think that's pretty legible there. Most of these, especially the first group, they're going to be pretty quick. You can just write them down below.
What's the exponent for 36?
36 is a 1/3. Yeah. Yes.
If my